Alright, so we got a question on the ed board about 9.5, problem 9.5a. For each of the following algebraic expressions for the Laplace transform of a signal, determine the number of zeros located in the finite S-planes and the number of zeros located at infinity. So let's just start out by giving this a name. We'll say it's h of s and it's equal to 1 over s plus 1 plus 1 over s plus 3. And that's going to be equal to s plus 3 over s plus 1 and s plus 3 plus s plus 1 over s plus 1 s plus 3, and that's going to be equal to, we'll have 2, we'll factor out the 2, and we'll do s plus 2 all over s plus 1 and s plus 3. And typically a lot of times when I'm working Laplace transform stuff, I leave I leave everything with factors. I don't distribute too much. We will here in a minute, or expand too much. But so zeros occur occurred at two places. And that's when h of s either equals 0 or h of s approaches 0, right? So the first, we can find the 0 in the finite S-plane by solving for, so finite S-plane 0. We're going to solve h of s for when it's equal to 0, and that's going to yield, all we need to do is make the numerator equal to 0, so we'd have s is equal to -2, right? Because if we plug that in, h of -2, we get 2, -2 plus 2 over some stuff, and that equals 0. Now, to figure out if we have one at infinity, well, we're in the S-plane, so we need to let s go to infinity. So if we take the limit as s goes to infinity of h of s, well, that's going to equal the limit as s goes to infinity. And now I'm going to expand that bottom term, and it would be 2s plus 2 over, we'll have s squared plus 3 times 4s plus 1, right? Now when we're talking about taking the limit as s goes to infinity, well, this s squared is going to dominate, right? This s squared is going to be taking it's going to be much larger than anything else. So we can kind of say, well, that kind of goes to the limit of s as s approaches infinity of 1 over s, because if let's just say we, divide out an s from everywhere, something like that, well, this term's going to leave and this term's going to leave. This 2 really isn't going to matter. But so this is kind of what is important out of that, is that we get this right here, and the limit as s goes to infinity is going to be equal to 0. So we'll have a 0 at infinity, because h of s, the limit of h of s as s approaches 0, or excuse me, as s approaches infinity is 0. Hope that helps. Thanks.